Hello, this is Mrs. Lemke, and this video is to walk you through the problems that you may have missed while you were doing the Unit 7 review. I would like to remind you that it is important that you do the review questions yourself first, then check your answers, then be listening to this video. So bear in mind that you're going to get the best results on your assessment and in your knowledge going forward if that is what you did. All right, these first 6 questions are matching from a word bank. And so I'm going to show you here the solutions for them and then explain to you how it is that I knew each one. So first of all, let's talk about these maybe a little bit in terms of like partners, because there are certain ideas that kind of go together. So for example, number 3 and number 5, you might notice that those two look a lot of alike, right? They probably we did not even type both of those, probably copy pasted and changed a little bit, right? So if we're talking about x values, all real numbers except where there are asymptotes, that is the domain because I said x values, and then all the real numbers except where I have horizontal asymptotes, and I'm talking about y values, that's the range. So bear in mind that in your domain, the vertical asymptotes are exceptions to the domain values, and the horizontal asymptotes are exceptions to the range values. All right, another pair that I think should go together in terms of our discussion is statement 2 with statement 4. So statement 2 and statement 4 themselves do not look that alike. The answers do, though. So vertical asymptotes versus horizontal asymptotes. For vertical asymptotes, you want to look for values that are going to make your denominator 0. Now, understand there's going to be another situation that you will find when you are in your pre-calculus class that might cause a denominator to be 0. It's something called a removable discontinuity or a hole. We have avoided problems that lead to that in this particular class, but I do not want to lie to you. But in this particular class, anytime you are looking for a denominator set equal to 0, what you're going to find is a vertical asymptote. And that vertical asymptote, as I just mentioned, is going to be a place where your domain, where your function doesn't have a defined domain, okay? Then a horizontal asymptote is where you look at the end behavior of the function. So you're going to take the ratio of the leading terms of the top and the bottom, or possibly if you have like a fraction and then a plus or a minus sign after that with like a 3. There's one coming up in a little bit. Let me find it. Here it is. Number 9. Okay, that 8, we know that that slides a function up 8. So my horizontal asymptote is going to be at 8 because my graph moved up 8. So I'm either going to look at my vertical shift kind of number if there is one, or if I just have a fraction, I'm going to look at the ratio of the leading coefficients, okay, and that will be my horizontal asymptote. My x-intercepts and y-intercepts you could think of as being a partnership as well. If I plug in 0 for x and find y, that's a y-intercept. And if I plug in 0 for y, that might be equivalent to setting the numerator equal to 0 and solving for x. So I just like to, the way I like to explain it, because I like things that are kind of short and simple in my wee little brain, I like to just think of making a T-chart. Oh, heavens. Just one second. Okay, my stylus and arm and everything were just going crazy there. Okay, so I like to think of making a little T-chart like this one and just say, okay, if 0 is here and if 0 is here, this is how I find intercepts. So if x is 0, plug that in, find out what y is, that's my y-intercept. If I let y equal 0, plug 0 in for your y-coordinate in your equation, find out what x is, and that's my x-intercept. So that little picture is what I keep in my head for intercepts. Okay, in the next set of problems, lower part of that page, you have these 4 problems, and this is applied understanding of what we were just talking about. So in finding the vertical asymptote, I want to think of what would cause me to have 0 in that denominator, because I don't want to do that. Divide by 0 is undefined. Mathematicians don't like undefined things. So we would look for what would cause this denominator to be 0, or this one, or this one, or this one. Okay, so think about what would make that 0, and that is your vertical asymptote. So for example, -2 would be bad. Here, 8 would not be good. Here, negative 10. Here, might have to do a little thinking, but only a little. Right? Let that equal 0, and you get negative 2. So those are my vertical asymptote values. At this juncture, I would go out of order, and I would say, well, vertical asymptotes, they are related to domain. The domain is everywhere I do not have a vertical asymptote. So for instance, for this problem, I would say I need to split up my real number domain and have like a break or a split at negative 2. So this is a very long way of just saying x can't be negative 2 for my domain. Okay? Just interval notation, very fancy. Okay, and I would do similar things for the rest of those. So just ignore or omit from your domain the value that you just found for your vertical asymptote. For your horizontal asymptote, we have kind of two cases here. The first case is exemplified in number 7 and number 9, where we have a slide up. So in number 7, the slide is a vertical slide, but it's actually a slide down. I said up, but you know what I mean, like a vertical slide. So my horizontal asymptote is going to be at negative 3. And over here, my vertical asymptote is going to be at 8. And wherever my horizontal asymptote is, that's a split in my domain, or in my range. Sorry, almost said it wrong, okay? And I would check this with just looking at a graphing calculator just to make sure that I was right. But my range here is going to go from negative infinity to negative 3, and from negative 3 to infinity. Okay, there's going to be a split, that horizontal asymptote. Now this you actually probably should check with a graphing calculator, because it is possible to have a horizontal asymptote and then have your graph, this is just a random graph I'm drawing, by the way, you guys, and have your graph just be on one side of the horizontal asymptote. That is possible. It doesn't happen in any of these problems, but just you should double check that, okay? Just look at your graphing calculator, put this in your y equals, right, and just look at a graph of it in your standard window, Zoom 6, okay, and just make sure that you are indeed above and below the horizontal asymptote. Okay, these are answers for 7, 8, 9, and 10. And hopefully you have an idea of how I got each of those now. Understand that these two answers work together, and like these two answers work together. Okay? All right, and the next one, you are matching. So you're supposed to match the graphs with the equations. So I just did this like kind of process of elimination. So for example, this one, I know that I don't want to be dividing by 0. And so the thing that would make the denominator be 0 is if x were 3. So I don't want, that graph can't have any graph at 3. And so that makes it this one, right? Because there's a break in the x values at 3. And then to double check that, this +1 would mean scooching up 1 or sliding up 1. And it looks like that happened because look at this horizontal asymptote at 1. So this one's B. All right, let's look at a different one. Let's look at one that just has a fraction and no extra number, okay? So in this one, I know that x can't be 1 because that would make the denominator equal 0. So it might be confusing that I wrote not equals here and I wrote equals here. This is the vertical asymptotes equation. So this line is named x equals 3. X can't be 3 in my function here, right? If I substitute in 3, I'm going to get something that isn't a number because I'd be dividing by 0, and that's not a number, okay? Just like if you substituted in Q in place of the X, you wouldn't get a number either, okay? So in number 12, I wrote X can't be 1 because I was thinking about domain, okay? So the vertical asymptote is at 1, and I look at my options here, and it looks like it must be this guy, right? Because that has a vertical asymptote at 1. And then to double check, I'm going to look here and say, oh, that ratio of leading coefficients, 2x over x, is just like having 2. And look at that horizontal asymptote at 2. That looks delightful. Okay, so that's the idea of those. You can see my other two answers done the same sort of way, same sort of processing. All right, the next group, it's an interesting group. The first one really is about exponent properties and division. So I have 10 and I have 4. So 10 over 4 is a fraction that can reduce. And since 10 over 4 is a regular fraction that can reduce, I went ahead and I wrote that as 5 over 2. Now, there are 8 x's on top. X, 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 written out 8 times. The bottom has x, 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 so 3 of those x's would cancel 3 of these. But I'd still have 5 more left over. So I have x to the 5th on the top. And then these 3 y's would cancel 3 of those y's, but I'd still have some left over. So that's going to be my overall answer, 5x to the 5th over 2y to the 4th. The things that are common factors in here, the things that are common factors, top and bottom, they can cancel. Okay, but they have to be factors. Okay, so speaking of factors, 16 isn't written with factors at all. Sometimes people are tempted to do kind of illegal things here, like they see the x squared, blah, 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 x squared, blah, 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 and they're like, oh, 2x, but x squared and the x squared cancel. Those are not factors, though. They're being added and subtracted to other things that are in the expression. In order to have this kind of canceling in my highlighted yellow circle, you have to be multiplying only, multiplying by something else, not adding, not subtracting. And you can see that the x squared is being added. The x squared has minus 6x right next to it, right? So that's not a factor. That's like a term, okay? Now, with that said, we can factor the top. Now, if you are still struggling with factoring, my friends, you really, really, really just have to practice it. That's all it is. Get yourself, some good problems to do online. They are not hard to make yourself. I think I explained that in another video that I said to you. And I just factored this wrong because I was talking at the same time. I just realized that. Did that cause you a moment of panic? It caused me a moment of panic when I saw it just now. Yeah, 3 times 4 is 12. 3 plus 4 is 7. Let's all revisit that. So as I was saying, you can learn factoring by practicing, and you can even catch mistakes that you make because you've practiced enough. That's my point. Okay, so we factored the top, factored the bottom. Common factor. So now those can cancel because, see, times. It's connected with multiplication, so that's a common factor. So now I've got x plus 4 over x minus 9. That is my final answer. I cannot, no, do that. The x's are connected with adding and subtracting. They aren't factors, they are terms. The red is as good as it gets. Okay? In question 17, we again get to factor. So I need 2 things that multiply to 8. Let's see, 4 and 2. And I need the middle part to be positive 2. So that would be the way my signs would have to go. And then I have a common factor. See that multiplication? So my final answer is x plus 4. This last one, x minus 4 on top. Common factor of 3. And then x squared minus 16 is a difference of squares. So I will use my difference of squares pattern, and then I have a common factor that can cancel out. Here it is more neatly. Okay, the thing that is left on the top of that last fraction is just a 1. Okay, I think I need to talk through these. Okay, question 19 has fractions that are being subtracted. They already have a common denominator. So that's awesome, right? We're going to subtract across the top. So x minus 3 minus x minus 9. And then keep the same denominator. Just like if you had 5 12s plus 1 12. You would just add across the top. If you had subtraction instead, then you would subtract across the top and keep the same denominator, right? 1/3 plus 2/3 is 3/3. That kind of idea, okay? So having the common denominator means we can just add across the top or subtract across the top. Notice here, this subtraction applies to everything after it, right? I was subtracting this whole thing. So the most common mistake on this one is this symbol that I'm writing right now, that. If you have minus there, what you forgot to do is distribute that negative. That subtraction pertains to everything after it. Okay, then x minus x is a big old 0, and negative 3 plus 9 is 6. Okay, the next problem does not have a common denominator, so we're going to have to do a little work here. I'm going to write down my problem, and then I'm going to find a common denominator by multiplying by strange versions of 1. Each of the things that I wrote in red is equivalent to 1. This equals 1, and this equals 1, okay? And I'm using those special versions of the number 1 so that the two pieces of my problem will now have the same denominator. That denominator is x plus 5 times x minus 7. If you look over here on the left, 4 times x plus 5 is what I have. Here's that addition sign. Over here, I have 3 times x minus 7. And then I can tidy that up, distribute, and combine like terms. Okay, I'm just going to show you that on the next screen. Okay, so here's the distributing, here's the combining like terms. Okay, question 21 is a multiplication problem. And to have this as simplified as possible, we are going to look for things that help kind of cancel out. So the 6x on the top and the 2, well, first let me say this. I'm sorry, I'm getting ahead of myself. When you multiply fractions, you don't need to have a common denominator. Everything can just smush. So say I had that. Now, I'm going to write things in a way that helps me organize. So I'm going to put this 2x over here and the x plus 1 after it. Is it okay to multiply in a different order? Is 2 times 3 the same as 3 times 2? Yes. So we can multiply in a different order. Okay, and then over here I'm going to do something else. I see that there's a common factor of 5. So I'm going to factor that out and see if I can get anything to drop. So for instance, x divided by x is 1. So I don't need to write like an extra 1 in the problem. And I notice right here, I have a difference of squares pattern. I also notice that right here, 6 divided by 2 is 3. So I've got 3 from the part I highlighted blue. The x over x is gone. I've got 5. This underlined part is x plus 1 and x minus 1 when I do the difference of two squares pattern. This over itself makes another 1. And so in that problem, all I have is 15 times x minus 1. I could also distribute this as part of my answer. That is also fine. All right. Now we have some more operations with rational expressions. I think I will, do I think I can put all this in one video? What do we think, guys? I think I'm going to pause here just to break it up, okay, and help people find their problem easier. So if you need help with the rest of the problems, be sure to check the second video.